good day and I welcome you to Physics with Paul and me. Alright, so today we have our Jamb 2026 practice question because we understand that Jamb is just a month from now. Okay, so we have to start our preparations and run with that same energy. This morning we have a question on the parallel coplanar forces where we look at the principle of moment, which states that the moment about an axis in the clockwise direction is equal to the moment about an axis in the anti-clockwise direction. Okay, so in that light, we have a question quickly. Let's solve. It says a uniform meter rule is balanced on the knife edge. So first of all, we have a uniform meter rule. Let's do a rough sketch of that. A uniform meter rule, and a uniform meter rule is usually 100 centimeters in length. It's usually 100 centimeters in length. All right. Then it went further to say that this meter rule is balanced on the knife edge 55 centimeters from one end R. Alright, so I'm going to take this first end as my end R, and the knife edge is placed 55 centimeters from end R. Alright, so here is marked at 55 centimeters from the 0 point mark. It means that we'll be having 45 meters remaining from here to here. We'll be having 45 centimeters rather remaining to these other points. Okay, so it now says that if a 10 kilogram mass is hung at the other end P, so it means that this other end is P, and at this end is a mass of 10 kilogram hung. All right, so the 10 kilogram mass was hung at this point, and the question goes as thus. It says, what is the mass of the meter rule? All right, we understand that for a meter rule, the center of gravity is the point where the mass of that body is concentrated. So what is the center of gravity of a uniform meter rule? The center of gravity of a uniform meter rule is located at the midpoint of that meter rule. Okay, and if this meter rule is 100 centimeters in length, it therefore means that the center of gravity where the mass of the body is concentrated is at the 50 centimeters mark. All right, so I'm going to mark here as my 50 centimeters mark. So here is 50 centimeters mark where the mass of the body is concentrated. All right, so we'll now go further to get the mass of the rule. It is at this point that the meter rule balances. So here's where my knife edge is placed. My knife edge represents the turning point, so I'm going to take my moment about the turning point. Okay, so let's quickly do that. For moment, we say that for moment the clockwise moment must be equal to the anti-clockwise moment. From where the mass is placed to the turning point, from where the mass is to the turning point. All right, and moment is defined simply as a product of the force that acts around a point and its perpendicular distance to that point. All right, so it means that I'm going to consider my clockwise. I'll call that clockwise moment, and this I'll call anti-clockwise moment. All right, I'll just put them in short from there. Okay, so if I consider my clockwise moment, the force or the mass placed there is 10. It will be multiplied by the distance of this mass 10 to the turning point. All right, if this knife edge is placed at 55 centimeters and the whole length is 100, it therefore means that 45 centimeters is the distance between the 10 kg mass and the turning point. So this is going to be 10 times 45 equal to, then I'll consider from the anti-clockwise moment. The anti-clockwise moment represents the mass of the meter rule and the distance of that center of gravity to the turning point, which is the knife edge. All right, so I'm going to get the mass of the body times what distance will be left if this knife edge is placed at 55 centimeters and the center of gravity where the mass of the body is concentrated is 50 centimeters. It therefore means that in between the center of gravity and where the knife edge balances is 5 centimeters. So this will be mass of the meter rule times 5. Okay, so I'm going to say 10 times 45, that's 450. This will be equal to 5m. Okay, so the mass of the meter rule will be 450 divided by 5. Therefore, the mass of the meter rule is giving us 90 kilograms. This is the solution to this particular Jamb practice question. All right.